Imagine this. You're sound asleep, it's the dead of night. Your phone is charging peacefully on the nightstand, a silent sentinel plugged into its cable. All seems calm and quiet. Suddenly a strange hiss pierces the silence, an unsettling sound that doesn't belong. It's a high-pitched whine, almost like escaping steam. Then, a whiff of burning plastic fills the air, acrid and sharp, stinging your nostrils. It's a smell that instantly triggers alarm, a clear sign that something is terribly wrong, and then, BAM! Your phone erupts in flames, a sudden violent burst of fire and sparks jolting you awake in a panic. This isn't a scene from an action movie or some special effect. It's a real and terrifying risk that's happened to people worldwide, a shocking reality documented in news reports and personal accounts. The very device that connects us to everything, our lifeline to the digital world, can, under rare and specific circumstances, transform into a dangerous fire hazard, posing a threat to your safety and property. The culprit behind this fiery outburst? A battery explosion, or more precisely, a phenomenon known as thermal runaway, a chain reaction of escalating heat and energy. It's a dramatic and catastrophic failure of the tiny power pack nestled inside our beloved gadgets, a hidden danger lurking within. But what exactly transforms a helpful battery, designed to power our lives, into a miniature volcano spewing fire and destruction? It's not magic or some mysterious force, it's simply chemistry gone terribly wrong, a delicate balance disrupted with explosive consequences. Batteries are a carefully engineered system, a delicate balance of specific materials and stored energy, all working in harmony. When that carefully maintained balance is disturbed, whether by damage, defect, or misuse, things can quickly go very, very wrong. To truly understand why these explosions happen, let's shrink ourselves down to a microscopic level and take a look inside the battery itself. We'll examine the intricate components, see what makes it tick with reliable power, and ultimately, what can make it explode with dangerous force. Batteries power nearly everything in our modern world, from our smartphones and laptops to electric cars and even entire power grids. But with great power comes great responsibility, and understanding the potential risks is crucial for safe usage. Knowing the science behind these failures, the underlying chemical processes, helps us prevent them and mitigate potential dangers. So, let's dive into the fascinating and sometimes undeniably dangerous world of battery chemistry, exploring the reactions and materials that make it all possible. This is essential knowledge, not just for scientists and engineers, but for anyone living in the digital age, surrounded by battery-powered devices. Ready to embark on this electrifying journey? Let's put on our metaphorical safety goggles and get started, preparing to delve into the core of battery technology. The story of battery explosions is ultimately about understanding the risks and potential hazards behind the technology we rely on every single day, the devices that have become indispensable parts of our lives. By learning about these risks, we become safer, more informed, and smarter users of technology, capable of making responsible choices. So, with a sense of curiosity and caution, let's begin our journey deep inside the battery, uncovering the secrets of its power and its potential dangers. What is a battery? Think of it as a tiny self-contained power plant. Its job: store chemical energy and release it as electricity when needed. This is what powers your phone, laptop, and even your toothbrush. Without batteries, we'd be tied down by cords. A battery is like a controlled, slow explosion, releasing energy in a steady stream. Inside there's a negative side, anode, a positive side, cathode, and a chemical soup, electrolyte, separated by a thin sheet. The anode and cathode want to react, but the separator keeps them apart. When you use your device, electrons flow from anode to cathode, through your device, creating electricity. The battery keeps working until it's out of electrons to give. For rechargeables, plugging in reverses the process. It's a beautifully engineered system. Batteries give us freedom and portability, but their power comes with risks we need to understand. Let's zoom in on the lithium-ion battery, the star of modern tech. Found in phones, laptops, and electric cars, these batteries pack lots of energy into a small space. That high energy density is what makes our gadgets slim and powerful, but it's also what makes them potentially dangerous. The anode is usually graphite, the cathode is a metal oxide, and the electrolyte is a lithium salt in an organic solvent. Lithium is light and highly reactive, it loves to give away electrons. Charging your phone pushes lithium ions from cathode to anode, storing energy. Using your phone reverses the flow, powering your device. This cycle can repeat hundreds of times. The separator, a thin plastic sheet, keeps anode and cathode apart. If they touch, electrons rush through, releasing all the energy at once. That's when things go wrong. The separator is the only thing standing between safe power and disaster. Next, let's see why these guts can be so dangerous. Lithium-ion batteries are marvels of modern technology, powering everything from our smartphones to electric vehicles. But these compact powerhouses are packed with an incredible amount of energy. They also contain highly reactive materials, carefully combined to store and release electricity. These materials, while essential for battery function, also present potential hazards if not properly contained. That's what makes them work. The controlled interaction of these reactive substances is what allows us to power our devices on the go, and what makes them risky. Understanding these risks is crucial for safe handling and use. The electrolyte, for example, is a flammable organic liquid, a key component in facilitating ion movement within the battery. It's definitely not water. Unlike water, it's highly combustible. It allows lithium ions to move freely between the anode and cathode, which is essential for the battery's charging and discharging process, but it's also a potential fuel source in the event of a battery malfunction. As long as everything stays in place, the temperature remains within safe limits, and the battery operates under normal conditions, it's safe. But the separator, the barrier between the anode and cathode, is just micrometers thick, thinner than a human hair. If it's damaged, punctured, or melts due to excessive heat, the anode and cathode, which should be kept separate, can come into direct contact. This creates an internal short circuit, a dangerous situation within the battery. It's like connecting battery terminals directly with a wire, bypassing the intended circuit. All the stored electrical energy meant to be released gradually is discharged almost instantly. This rapid discharge generates intense heat within the battery cell. The heat rapidly boils the flammable electrolyte, turning it into a gas. This phase change dramatically increases the pressure inside the sealed battery. High temperatures can also cause the cathode material to break down, further exacerbating the situation. This breakdown can lead to the release of oxygen, feeding the potential fire. Now you have heat, a flammable fuel source, and a readily available supply of oxygen, the three elements of the fire triangle. And all of this is happening within a sealed metal can, creating a pressure cooker effect. It's the perfect and terrifying recipe for a fire or even a violent explosion. That's why battery failures, though rare, can be so incredibly dramatic and destructive. The tiniest flaw, a microscopic imperfection, can, under the right circumstances, turn a seemingly harmless battery into a potential bomb. Next, let's delve deeper and see what specific factors can trigger this dangerous chain reaction within a battery. When a battery experiences a catastrophic failure, the event is often referred to as thermal runaway, a self-sustaining, out-of-control reaction that can quickly escalate. It's a process where the internal temperature of the battery rises uncontrollably, leading to a cascade of events. Understanding what initiates this dangerous phenomenon is crucial. 4 main triggers can set it off: physical damage, which compromises the battery's structural integrity; heat, excessive ambient temperatures that push the battery beyond its safe operating limits; overcharging, a situation where the battery receives more electrical energy than it can safely handle; and manufacturing defects, hidden flaws introduced during the production process. Physical damage is simple. Drop or puncture your phone, and you might breach the separator, the thin membrane that prevents the anode and cathode from touching. A dent or puncture can cause an instant short circuit and fire, as the internal components come into direct contact. Heat is another culprit, and often an overlooked one. Leaving your device in a hot car or charging under a pillow can raise temperatures dangerously, creating an environment ripe for thermal runaway. High heat can melt the separator and break down the electrolyte, the conductive fluid within the battery, starting the runaway process. This degradation accelerates the internal chemical reactions, leading to a rapid temperature increase. Overcharging is risky too, and can have insidious effects on the battery's health. Cheap or faulty chargers can override safety circuits, which are designed to prevent overcharging and protect the battery, forcing too much current into the battery, even after it's fully charged. This can cause lithium to form sharp dendrites that pierce the separator, creating an internal short circuit. Manufacturing defects are the hidden danger, the silent threat lurking within the battery. Tiny metal particles or misaligned layers inside the battery, introduced during the manufacturing process, can create weak spots, areas of increased vulnerability within the battery's structure. These flaws might not show up for months or even years, but over time, they can cause a short circuit, leading to thermal runaway. That's why entire batches of devices sometimes get recalled, as manufacturers proactively address potential safety risks. Any of these triggers can start the chain reaction, setting off a cascade of events that lead to catastrophic failure. Once it begins, the battery's energy is unleashed in seconds, releasing a tremendous amount of heat and potentially igniting flammable materials. The result: fire, a rapid oxidation process that generates intense heat and light, smoke, a visible suspension of particles in the air, often containing toxic chemicals and sometimes explosions, a sudden and violent release of energy that can cause significant damage. Even the best designed batteries aren't immune, highlighting the inherent risks associated with lithium-ion technology. That's why safety standards and quality control matter, playing a critical role in minimizing the risk of thermal runaway. Let's look at some real-world examples, examining instances where these triggers have led to thermal runaway events. Battery failures have made headlines. The Samsung Galaxy Note 7 is infamous. Phones caught fire due to battery defects, leading to a global recall. Some batteries were too large and got pinched, others had welding flaws. Laptops from major brands have also been recalled for battery fires, often due to tiny manufacturing flaws. Hoverboards became a viral hit, but cheap, unregulated batteries led to fires sometimes while riding. These incidents show the dangers of poor design and quality control. Fires can be intense and hard to put out, causing injuries and property damage. The lesson: always choose certified, well-made devices. Safety standards exist for a reason. Battery fires are rare, but you can make them even rarer. Always use the original or certified charger. Cheap knockoffs can be dangerous. Keep devices out of extreme heat and never charge them under pillows or blankets. If your device feels hot, unplug it and let it cool. Don't ignore damage. A cracked, bent, or bulging device is a warning sign. Stop using it immediately. Never try to fix or puncture a swollen battery. Don't leave devices plugged in for days. Inspect charging cables, replace frayed or damaged ones. These simple habits keep you and your devices safe. Respect the power in your pocket. When a battery dies or is damaged, never toss it in the trash. In the garbage, it can get crushed and start a fire. This happens thousands of times a year. Always treat old batteries as hazardous waste. Take them to a battery recycling center or e-waste collection point. Many stores and facilities have special bins for safe disposal. If the battery is removable, tape over the terminals to prevent short circuits. For swollen or non-removable batteries, take the whole device to a professional. Safe disposal protects people and property, and the environment. Understanding battery risks is key to safety, and the future is promising. Scientists are working on solid-state batteries which use a solid, non-flammable electrolyte. These batteries are safer, more energy-dense, and longer-lasting. They could revolutionize everything from cars to phones. Until then, lithium-ion batteries power our world. They're marvels of engineering, but not without risk. Knowing how they work and how they can fail empowers us to use them wisely. Smart users are safe users. Treat your devices with respect and make informed choices. Knowledge turns fear into prevention. Stay curious, stay safe, and appreciate the science powering your life.